Folks, hello. Welcome to week 7. What I thought I would do for this week is go through maybe I picked out 4 problems from the homework set that I thought I would at least go through and help you recognize some potential pitfalls in this week's work. I think everybody will do very well. I just want to remind you of there's 4 different problems here. I just want to remind you of some things as you go through these problems. So I hope this is helpful for you as you get going on that problem set. This first problem, actually, it's question 1, and I've actually rewritten the problems over here just in case you can't see it here. But in this case, we're multiplying fractions. And just as a reminder, let me say that when we multiply fractions, remember, we just multiply numerators and denominators. We don't get, it's not like addition and subtraction where you have to have a common denominator in order to add or subtract. So we're just going to multiply numerators and denominators. So I've shown the problem here. The point I want to make here, whether the polynomials are as maybe a little simpler as you see here, or when you get into trinomials where you have to factor, the point I want to make here is that when you start multiplying fractions that involve polynomials, make sure that you factor first. And the reason I say that is because when you start multiplying these things all out, it may not be quite as easy to see the common factors. But if you start by factoring each numerators and denominators as best as you can before you multiply, you can come across the common factors and cancel them. So what I have done here with 4x plus 4y is I've taken out the common factor of 4. And with the 5 and 10, obviously 5 is prime, but I wrote 10 as 2 times 5. So before I would even start multiplying here, what I would do is I would cancel the x plus y here with the x plus y in the denominator here, and I would cancel the 2 5s. So in the end here, it looks like it would be what I would have remaining after I canceled the common factors, just 4 times 2 in the numerator, and then it looks like just 5, actually both of these things cancel in the denominator. So 4 times 2 over 1. So I think the final answer here would just be 8. So make sure, again, I think you'll find it advantageous to cancel or factor and then cancel the common factors before you start multiplying. Second problem I've got here, so division. Just as a reminder, when we divide fractions, remember when it's set up here kind of in a horizontal situation, remember the fraction that comes after the division sign is the divisor, and this is the dividend. And so we want to make sure that we when we divide fractions, that we remember the inverting or the inversion of the divisor, and then we multiply. So I have written the problem here, 9 minus j over 15 divided by j minus 9 over 24. So what I have done is I have inverted the divisor over here, and then I've multiplied. And similar to what I did here, I mean, this takes us back to the first problem that I showed you, where you're going to want to factor this the best you can before you start multiplying. What was pretty easy here, 15 is 3 times 5, and let's see, 24. 3 times 8. So it looks like we've got common factors of 3 that can be canceled here. A little trickery going on here. Notice we have 9 minus j here, and we have j minus 9 here. And I think you might have already come across this, but notice that these 2 factors differ by a negative sign. So as I went down here in the multiplication step, I wrote 9 minus j as 9 minus j. But over here, j minus 9, I wrote this. I factored out a negative 1. And when I factor out negative 1, I can rewrite this as j minus 9 so that I can cancel these 2 factors of 9 minus j. But just to make sure this is clear, when I factor this out, if I were to distribute the negative 1, this would give me minus 9, and this would give me plus j. So I have not changed this expression. I have just rewritten it such that I can cancel the factors of 9 minus j. So you can, once you go through and cancel any of the common factors here, you'll be all set on the final product. Third type I have here, this is where you're going to get into this business of rationalizing denominators. The bottom line here being is that when we have rational expressions involving radicals, we typically do not want any radical expressions in the denominator. So we're going to go through this process of what we call rationalizing the denominator. So if I start with 14 over 8 minus 5 times the square root of 2, you've come across a discussion of something called the conjugate, conjugat in your reading. And it's basically, if you think of this in the format of just A minus B, the conjugate would be A plus B. And we know that from the factored form of the difference of two squares, if I have A minus B times A plus B, then I'm able to get rid of the two terms in the middle when we look at this as a FOIL situation. So the bottom line here being, excuse me, when I start here with 14 divided by 8 minus 5 times the square root of 2, what I'm going to use is I'm going to use the conjugate of 8 minus 5 times the square root of 2, which is going to be 8 plus 5 times the square root of 2. And notice I'm going to multiply both the numerator and the denominator by 8 plus 5 times the square root of 2. Obviously, this by itself, 8 plus 5 times the square root of 2 over itself, is equal to 1. So effectively what I'm doing is I'm multiplying this original rational expression by 1, so I don't change the value of it. But what I'm going to do here is I'm going to be able to get rid of the radicals. So when you go to the next step here, obviously you're going to multiply the numerator. So this basically is going to look like the distributive property. So 14 times 8 and then 14 times 5 times the square root of 2. Whatever that comes out to be, I said, well, that's a question mark. You all can handle that. What I wanted to be very explicit about here is making sure you understand why this conjugate works. So if I have 8 minus 5 times the square root of 2 times 8 plus 5 times the square root of 2, this is really a binomial times a binomial. So when I FOIL this out, I have 8 times 8, which is 64. 8 times 5 times the square root of 2 is 8 times 5 is 40 times the square root of 2. And then 8 times minus 5 times the square root of 2 is minus 40 times the square root of 2. And then when I multiply minus 5 times the square root of 2 times positive 5 times the square root of 2, I get minus 5 times 5, which is negative 25, and then the square root of 2 times the square root of 2 is just 2. So effectively what I get here is I get minus 25 times 2, which is minus 50. But the bonus here of the conjugate, if you notice these two terms here in the middle, I have positive 40 times the square root of 2, and then I have minus 40 times the square root of 2, and those will cancel. And so what I'm left with in the denominator is just 64 minus 50, or 14. So that will then allow me to simplify this to the point where I may have a radical expression, and it looks like I will have a radical expression in the numerator. But again, when we rationalize a radical expression, we don't want the radicals in the denominator. So that will be the step that you go through when you get into these rationalize the denominator sorts of problems. Just make sure that you're clear on what the conjugate will be in each case. And then finally, one of the things that we typically, and I've mentioned this a couple times with regards to factoring, now that you've gotten into the mode of factoring, you will not get out of the mode of factoring, at least through Math 112, which is that combination of Calculus 1 and Calculus 2. That will be an important skill for you to maintain from here forward. And what we are going to use it for now, obviously we spent a lot of time last week factoring polynomials, but what we're going to use now is we're going to use that skill in order to help us solve polynomial equations. And notice now, instead of factoring, we've changed the language here to solve the equation, and notice that we do have an equality in here at this point. So some of the problems that precede this in the homework say to write this in standard form or general form. And when you're trying to solve an equation involving a polynomial here, a second degree polynomial, this general form or standard form will require you to take all of the terms and put them on one side of the equation so that the equation, or so that the polynomial effectively is set equal to 0. So if I start with x squared minus 3x equals 10, the first thing I'm going to do is I'm going to subtract 10 from both sides. So I get x squared minus 3x minus 10, and I'll set that equal to 0. So now this is in standard form, and you can go forward and try to solve this. And we're going to solve this by factoring. And what I notice here, if I just look squarely at the polynomial, if I can find factors of -10 that add to -3, then I can factor this. And those, of course, would be -5 and +2. So I can factor the left-hand side as x minus 5 times x plus 2, and that product is equal to 0. And as you go through the reading this week, you'll read about what's called the zero factor property or zero factor principle, which says effectively, if I have two factors and their product is equal to 0, the only way that can happen is if one or both of these factors is equal to 0. So once I get to this point, I've again factored the polynomial, I've set it equal to 0. And again, just reminding you, this is a product. This is x minus 5 times x plus 2, and that's equal to 0. So the only way that this can be equal to 0 is that if x minus 5 is equal to 0, and when x minus 5 is equal to 0, x must be equal to 5, or x plus 2 has to be equal to 0, and when x plus 2 is equal to 0, x is equal to -2. So when you notice here, when it says solve the equation, and if you go back over here and it says x equals in this top line, the instruction says use a comma to separate answers as needed. So typically what you're going to find on these, I shouldn't say typically, what you're always going to find is that in a second degree quadratic equation, there's always going to be two solutions. And here your solutions are 5 or -2, not 5 and -2 at the same time, but 5 or -2 makes this polynomial equation true. So again, I think the big thing here is absolutely being careful about making sure that you have these equations in general or standard form first. Again, that meaning all the, whether they be variable or constant terms, are on one side of the equation, and that is set equal to 0. And then obviously if you can factor this equation, or I'm sorry, not this equation, if you can factor this polynomial, obviously you're in good shape, and then you can or apply the zero factor principle or property, whichever you want to refer to that as, and then you can set these binomials or linear binomials in this case equal to 0 and very easily solve for the variable in each case. So again, that's just kind of a smattering of the homework problems that you're going to see this week. But like I said, I think in each there's just a quick point that is important to make so that you're not turning these problems into something that's far more onerous than they need to be. Just be very careful that you're, especially when you're multiplying or dividing rational expressions, make sure that you factor and you cancel common factors before you start that. That will save you a lot of grief in the end. The other point we brought up here is this idea of the conjugate that we use especially for rationalizing the denominator in a rational expression involving a radical. And then finally here, now we're into the solution business here, where we're solving second degree polynomial equations. And typically the first way that we will try to do that is by factoring. Obviously there's some other techniques that we'll learn along the way, but I thought what I would express to you here is one involving factoring, just to stress the point that from here forward, at least until you get through Math 112, don't lose sight of how important the factoring is going to be. So I hope this is helpful. If there's anything else I can do for you, please let me know, and take care. And I look forward to a lot of good work this week in the homework and on the discussion board. Thanks.